Yes, good evening, everyone. Good evening. Am I audible? Good evening, Salman. Good evening. Okay, Bhumin, thank you. So let's start the session without any delay. Good evening. This is Dr. Saurabh Anand. We are going to start the new unit that is related to transistors. So in earlier unit, we discussed about what is transistor, what is the basic operation of transistor, what is the use of transistor. So today we are going to discuss about the use of transistor as an amplifier. Okay. So before that, we should know what is transistor. The transistor is nothing but the three region device having emitter, base, and collector. And using those three regions, it having two means three modes: active mode, saturation mode, and cutoff mode. So for amplification means if we want to use transistor as an amplifier, we have to use in active mode. In active mode, two junctions are there. So first junction should be forward biased and second should be reverse biased. So we will discuss all these things in today's session. These are the common guidelines that you have to follow. This is the topics that we will discuss today. What is transistor? We will give the overview. What is the use of transistor that is as an amplifier? We will understand it. We have a different transistor also, that is field effect transistor. In short, we write FET, and the types of FET, that is JFET and MOSFET. So these are the outcomes after the completion. You can explain what is transistor, how the transistor work as an amplifier. We can understand. You can also describe the transistor family like FET and MOSFET. Also explain the characteristics of FET and MOSFET both and application of transistors. So let's begin with the topic, that is transistor as an amplifier. So we have already understood what is transistor. So this is the symbol of transistor like this. Whosoever was not in that session, you can understand. This is the symbol. So whenever we draw any circuit, then we use the symbols. Okay. So we have two types of transistors, PNP and NPN. So I told you in which transistor the arrow. So arrow is always drawn at the emitter terminal. So wherever, suppose here it is arrow, so it will always be emitter terminal. It will also be emitter. Middle will be base, middle will be base, and remaining will be collector. This is collector. Okay. So this is outside. So it is NPN, and this is inside. This is PNP. So these are the symbols of PNP and NPN transistor. So here we are using NPN transistor. Okay. So we have drawn it like this. But these batteries, this battery and this battery, are used for biasing. So what is biasing? Biasing is the process of connecting or adding the battery in the circuit, and these are for biasing purpose. Biasing means we have to start this transistor. Suppose you have a TV, right, and setup box at your home. So if setup box is not on, can you watch anything on your TV? No, because setup box will be providing the signal, and if it is not switched on, then we cannot watch movie or anything on the TV. Okay, so similarly, we have to on this transistor. So for making this transistor in on condition, we have to use, here we have to do biasing, and for biasing we use battery, right? So this is this battery, this is second battery. Why two batteries are used? Because this is the block diagram of suppose PNP or NPN transistor, any transistor, right? So this junction, this is J1, this is junction J2. So this junction full should be forward biased and this junction should be reverse biased, right? So suppose we are using NPN, so I am using NPN, right? I am changing it because we have NPN here, so I will write NPN. So this is N, this is P, this is N, right? So for making this junction forward bias, this N should be connected with the negative terminal of the battery like this. Okay. And for reverse biasing, this N should be connected with positive like this. So same process. So this is battery VEE, this is battery VCC. Why VE? Because this is emitter region, this is base, this is collector. So for emitter it is EE, for collector it is CC, right? So this negative is connected with emitter terminal. So emitter is here, right? So this negative is this side. Okay, got it? Why battery is like this? You can ask me that sir, here it is like this, but you are drawing here opposite in the direction, right? So because emitter terminal is here and this emitter should be connected with the negative terminal of the battery. So negative is here. Got it? Have you all understood why this battery is drawn like this? Okay, thank you. Now, second battery we have to connect this. This collector terminal is connected with the positive of the battery. So this collector is here. So this is connected with the positive of that. Okay. So this battery will make this junction, that is J2, reverse bias, and this battery will make first junction, that is between emitter and base, forward bias. So we are basically using active mode, right? In active mode, J1 should be forward bias, J2 should be reverse bias. So we have done. Now this is base terminal, so current will be IB. This is collector, this is IC, right? At base terminal, the current will be known as base current, collector terminal, base current, emitter terminal, emitter current, right? So as this direction is here, so current will be drawing like this. It will come like this and this. So this IB will be inside. Okay. This positive is here. So current will be drawing in this direction like. So this IC will be inside. So if you draw, we have studied KVL and KCL. So if we replace this transistor by this node, and this is IB, this is IC, and IE is here, so obviously IE will be in this direction. This is IE. So if we write the equation using KCL, so all the incoming current will be equal to outgoing current. So how many currents are incoming? IB and IC are incoming, so it will be added, and one current is only outgoing, that is IE, so IE will be. So this is the same transistor equation that we have already studied. We studied this equation in transistor chapter, that is IE is equal to IB plus IC, right? So this is known as transistor equation. So you can understand this from here, and we can also verify the direction of the current that we are showing in the circuit. So IB, IC should be correct. Okay. Any problem in the direction of the current? Any one of you? Okay, Chanchal. Now we come to the voltage that we are showing here. So it was also discussed in the circuit. So this is base terminal and this is common. So this whole line will be known as emitter line. Okay. So whatever we are applying to any circuit, we apply with respect to ground. Okay. We apply the input to the main line with respect to ground. If we want to take the output after processing, we take at the main line with respect to ground. So ground is common for applying input and taking output both. So we are applying at base with respect to, this is emitter, we can write here E. Okay, so we are applying input at base with respect to E. So voltage which is applying at base will be VB, but with respect to E, so it will be VB. Similarly, we are taking output at collector terminal. So voltage at output will be VC, but with respect to E, so it will be VC. So you can see this is VB, this is VC. Okay, got it? So these are the voltages that we are applying and getting at the output side. And finally, what will be the amplified output? This is the output of only transistor, right? This is RC. So this RC is actually treating like the output resistance. We can write R naught also. Okay. R naught means O. It is O for output. So this resistance is for taking the output. So what we want at the output side? We want some voltage, amplified voltage. How we can get the output voltage? That means, where is, sorry. So V should be equal to IR. So we want actually V out, that is output voltage. So we should have resistance, that is R out. The current which will be flowing here, right? That will be IC obviously. So IC will be multiplied with R naught. So that is why the current which is flowing through it will be in this direction IC. So IC into RC according to this circuit will be V out. Okay. So V out will be IC into according to this circuit. If we write R naught, then we will write IC R naught, whatever. Got it? So you can see here what is this and what is this. This is amplified output. So you can see that this is the amplitude of the signal. What is amplitude? I am just drawing here. I am drawing here. This is the height of the signal is amplitude. So this is what? Amplitude, right? After amplification, you can see it is increased, right? It is same in positive as well as negative, but increased. So that increment is known as amplification. But what is this? Here it is starting like this, and we are getting like this. What is this? So this is known as phase. This is known as phase change. Okay, phase is changed. How much? It is 180 degree. 180 degree. How 180? So whenever we draw this, so this is the angle which is between this is 2 pi. Pi is 180. So it is basically 360. Right? But what is the change? It is only not, we are not getting from here, we are getting from here. So half is 180. So how much phase difference is there? This changes difference actually. So phase difference is of 80 degrees. Right? Any doubt? Please just a minute, hold on. Sorry. So have you understood how it is 180-degree phase shift, right? So it is shifted by, it is not, we are applying from here, but getting the output from here, like this. Okay? But amplified. It is amplified, but after 180-degree phase shift, we are getting the output. So this is known as 180-degree phase difference or shift. Okay? So I want to just show you why we are getting. So transistor provides 180-degree phase shift or phase difference in the out. So suppose we want the same phase. So what do we do? What do we do? Right? We will again add one more transistor. So that is amplified again. I'm just drawing here. So after applying this, we are getting here. We will again apply to second. This is after first transistor. We are adding one more transistor. So we will again get the same but more amplified like this. If we again add this, we will again add like, okay. So it works in this manner. We will get the amplified but after 180-degree phase shift. But if we want the same phase, we have to add one more transistor. So this and this are in same phase but amplified, right? This and this are out of phase but more amplified. So if we want to make the same phase or maintain the same phase, we have to use in odd even numbers. If we add only odd numbers like 1 3 5, we will get 180-degree out of phase. Got it? Are you getting this thing? So if it will amplify more and more, but in phase, out of phase, in phase, out of phase, like this. Got it? Okay, Bhumi. Thank you. Now we have another type of transistor that is actually unipolar. The transistor that is BJT. What we studied, that was BJT, bipolar junction transistor, right? That was bipolar. Bipolar means the conduction is due to both electrons and holes. So holes and electrons both are playing the role in conduction. Means to flow the current, both will work. But in case of FET, only one charge carrier, either hole or electron. Both will not work. Only one charge carrier is required. It may be electron or hole. Okay. So FET is unipolar, and that transistor PNP and NPN were BJT, that was bipolar junction transistor. Bipolar means bi means two, uni means one. So bi means two poles, means two charge carriers will work, and in case of FET only one charge carrier will work. It may be electron or hole. Okay, one at a time, not both. So as the name suggests, field effect transistor. So field effect. The effect is of field. What effect? Effect means if we vary the field area, okay, then the conduction will also vary. And what is conduction? Conduction means the flow of charge carrier. And flow of charge carrier is nothing but the flow of current. So ultimately the flow of current can be controlled by the field, that is the area of the field. Okay, right? So have you understood the name, that is field effect transistor? That means the effect on the charge carrier is of the field, the area through which it is flowing. And if we vary that, the flow of current will be varied. So this is a special type of transistor. This is also a transistor because last T is transistor. Okay. but the field is used to control the flow of current. Okay, so how we are controlling the current? We are controlling the current after controlling the flow of charge carrier. If charge carriers are more, then the current will be high. If charge carrier are less in number, the current will be less. That's all. Okay, and these transistors are used in modern electronics. MOSFET, you might have heard MOSFET. Okay, so this is the modern electronics in which we are using FEDs. Okay, so this is unipolar, as I told you. So how we develop or use that, we will study here. So FET is basically initially, and anything, suppose anything has two types. So initially nothing has two types. In the beginning there will be only one. So actually FET was developed in the beginning. First, FET was developed, and after the means research on that or any other structure changes or anything, then second was developed. Then first was named as JFET. So initial FET is actually nothing but JFET, that is junction field effect transistor. Okay, and the second which that was developed was known as MOSFET, that is metal oxide semiconductor field effect transistor. So JFET, FET actually both are same, both were same, but after developing the second type, then first जो field effect transistor that became actually JFET, and second developed was known as metal oxide semiconductor field effect transistor, MOSFET. It is known as MOSFET, right? These are the symbols. I will explain you like PNP and NPN. Okay, you need not to learn this symbol. Okay, it is drawn here, but no need to learn. I'll tell you why it is dotted like this. Okay, I'll tell you everything. In one MOSFET, it will be completely connected. So it is broken actually, right? I'll tell you. So as I told you that JFET was initially developed, so it is simplest type of FET, right? So it was initial FET, that is JFET, right? And this is voltage control device. What do you mean by voltage control device and current control? So BJT are current control. So basically, what we are doing, we are controlling the current. In case of FET, what we will do, we will control the voltage, right? So you should know which is voltage control and which is current control device. In JFET, the current flow is due to majority charge carrier. So what I told you, it is unipolar. So unipolar means it may be there may be electrons or holes. So if electrons means that will be n type, holes means that will be p type. But in n type, it is there will be holes also, but in very less number, minority charge carrier. So we will talk about only majority charge carrier. So if we have E type, N type, then there will be electrons. If we have P type, there will be holes. Okay. But in case of BJT, the current flow is also minority as well as majority, both, because there was P and P, right? P and P. So there was leakage current also. So leakage current is low, is flowing due to minority charge current. Okay. But in case of JFET, we will talk about only majority charge carriers, not minority. And since only majority charge carriers are responsible for the flow, so it is unidirectional. So it will not be bidirectional. It will flow in one direction only, not in both. So it is a structure. So I'll go to this structure directly, not at that. So this is N channel, this is P channel. What is this? So channel means what is channel? Through which the electrons or holes will flow. Okay. So this is that. This is the this region is actually the channel. This is channel. This is the channel, right? So what type of and this channel? This is purple. This is also purple. This is also purple. All are purple. This is green. This is green. This is green. All are green. It means this bar, this bar. This is known as bar. This bar is made up of N type. This bar is made up of P type. So this is P type bar, this is N type bar. So we are using basically what is this? I am drawing one here, right? Like this. Initially, what do? We take one bar of any type. If it is N type, then N type. If we take N type, this. And diffuse two regions like this. So if it is N type, then it will be P type, right? If it is P type, then it will be N type. Opposite. And this region, this diffuse region, and this will be interconnected like this. And this becomes gate. And one terminal which is connected here is drain, and this is source. Similarly, this is drain, this is source, and both are connected and become gate. So whatever there was emitter, base, and collector in BJT, in JFET, emitter will become source, base will become gate, and collector will become drain. Right? In BJT, we start from emitter, reaches till collector. It starts from source, reaches till drain. Okay? And base and gate are the middle one. Got it? So have you understood how this structure was made? So these are the two structures. So whatever, if we are using N-type bar, then it will be known as N-channel JFET. If we are using P-type bar, then it will be known as P-channel, because this this region is of N-type. This region is made up of P-type. That is why. So P-channel means P-type channel. N-channel means N-type channel. Understood? Okay. Thank you, Pawan. Now, how does it work? Right? So, whenever this is suppose N type, then it will be of P type. Both will be of P type, right? So, if we join P and N, we have studied PN junction diode. So, after joining P and N, there was junction. So, similarly, this is that junction. This is that junction, and at junction, what happens? There becomes depletion region. Depletion region means immobile charge carriers. Electrons and holes will recombine with each other and will become neutral near junction. So this is the depletion region between P and N type. Similarly here, this is the depletion, right? After applying the voltage at gate, after applying the voltage at gate, we vary. This depletion region will increase or decrease depending upon what? At the voltage which we are applying at gate, right? And between drain and source, both. So what we will do, first we will apply the voltage between drain and source. Okay, whatever can be done. But controlling through gate, we apply at gate. That will be known as gate voltage. Okay. So according to the voltage applied, you can see here this width is more, it is wider, but this is very narrow. So it becomes, if it is wider, more charge carriers will move between drain and source. If it is narrow, then less charge carrier will flow between drain and source. Okay, so depending upon the number of charge carriers flowing between drain and source, accordingly there will be high or low current. So we are controlling the current by voltage. Okay, right? So what is the working? Working is that we will apply the voltage between drain and source first. What will happen? If it is n-type, we have to attract the electrons, and electrons can be attracted if we connect positive with this address. So current will flow here, right? Clear? Any problem? In n-type, it will be opposite. Why? Because if electrons are attracting here, so electron current will be inside. Okay. If it is p-type, then this current is correct, right? In p-type, it will be outside. Why? Because p-type means holes will be there. We will connect outside, then current will also be outside. So in p-type means p channel, it will be outside. In n channel, it will be inside. So you have to remember this thing. We will draw the symbol at the same time. This is the MOSFET, oh sorry, FET, JFET symbol. So if it is P channel, it is outside. So if it is outside, then it will be P channel. And if here it is 90 degree, right? In BJT, it was like this. You should understand that. It was BJT. Well, sorry, BJT, right? P and P and in N channel, it was inside. So it will be here. So in JFET, we draw the arrow at gate terminal. So this is gate, this is drain, this is source. This is drain, this is, sorry, this is gate, this is drain, this is source. So this is N channel. So this is, you can see here, that was done. So can you tell me which type of JFET it is? It is inside. Who will tell me? Here it is not written N channel or P channel GFET. It is only GFET transistor. But now you have understood in which type of GFET it is inside. So can you tell me? Any one of you? In which type of GFET it is inside? Bhuvan, Pawan, Shani, Ria, any one of you? Meenal. So this is N channel, right? I have just drawn here. It is inside. that was drawn here. Okay, so it is N channel MOS, GFET. Have you understood? How does it work? So this is all about the operation that we have understood. This is the output characteristics of JFET. So output characteristic between output voltage. So output voltage is between drain and source, and current will be ID. Output current in BJT was IC, and C is what? Drain here. So ID, right? Output voltage between V, C, E. Here it is. C is D and E is S here. So VDS. So we have drawn here. So we are increasing the VDS continuously and getting the ID. So at this we are getting this. Right? At this it is this. At this it is here. At this it is here. Right? So this is output characteristics. And similarly we have MOSFET. The structure of MOSFET is a little bit different. This is the structure. It is metal oxide semiconductor field effect transistor. Here we take one base, okay, that is known as substrate. Okay, substrate may be of P type like here, and we can take of N type. I am drawing N type and P type is already here, and this is N type substrate. What we will do next? We will diffuse two regions. Two regions. If it is N type, then it will be P type. It is P type, it is N type. And what is plus sign? So plus sign shows the high doping. So highly doped regions will be diffused, inserted. Okay. And we will connect one terminal here, second terminal. This is known as source, this is known as drain. And one terminal that is between drain and source is known as gate. So this terminal is not directly connected with this region. You can see here, it is not connected. That is why it is known as isolated gate. Isolated means separated. So it is also MOSFET is also known as IGFET, isolated gate field effect transistor. Okay, the second name of MOSFET is IGFET due to the structure because gate is isolated from the structure. Okay, and one terminal is also here. So MOSFET is not of three terminal, it is four terminal. So this is known as SS, that is body terminal. This is body terminal because this is body. So whatever we are connected with the body is known as body terminal and it is shown by SS. Okay. Okay. Now we have two types of MOSFET. One that we have drawn here, it is known as enhancement type, in which there is no, this is source, this is drain. Here it is nothing. But if we draw one channel, then it will become depletion type. It will become depletion type. So this is channel is of P type. So it is P channel enhancement type MOSFET. Enhancement type MOSFET. Now I will draw depletion type here. Okay. Whatever I have drawn will I will make it deplete. So this is the channel. Okay. This is channel. Sorry. And this channel will be of P type. Because this is P type, this is P type, so this channel should also be of P type. If it is N type, then channel will be of N type, right? Clear? So here we will have four types of MOSFET. Two of enhancement type means P channel enhancement, N channel enhancement, and two of depletion type. So this is the depletion type because we have drawn the channel. So if channel is present, then it is known as depletion type. If channel is absent, it is not there like this. Right here it is, there is no channel. It is known as enhancement type. Got it? So enhancement, no channel, depletion, channel. Right? So in this P type diffuse region, channel will be of P type. Now this is P channel. Okay, if we interchange, this N is P, then this will become N, this will become N, and this will become N. Then it will be known as N channel depletion type. Okay, so have you understood the difference between enhancement and depletion type MOSFET? Everybody, tell me. Okay, so which type of MOSFET it is? So here you can see here. MOSFET, enhancement type, depletion type. Enhancement has P channel, N channel. Depletion type has P channel, N channel. Right. Now the working. Okay. How does it work? So first, what we will do, we will connect the battery between drain and source. Same working like FET. We connect the battery between source and drain. Here it is not possible. I will draw here. This is source, this is drain. This is P type, this is P plus, this is P plus, then it will be of N type, right? This is again. So this should be grounded. It is understood, right? So what we will do, we will connect the battery between source and drain. What is the need? That is, this hole should be attracted, means should come outside. So what we can do, we can connect the battery like this. So this negative terminal of the battery will attract the holes outside, then current will flow. So current will flow outside, so ID will also be outside. And this source and this SS will be grounded. Grounded. Okay. And we have one gate terminal. So what gate will do? How much we are applying, this is variable. We are increasing the voltage, the more holes will be attracted, more ID will be there. If we want to control ID, then this gate voltage will be used. Okay, so gate will be applying the voltage here, that will be known as VGS. We will apply VGS, accordingly it will control the current. So what is the role of gate? So gate will increase, it will increase or decrease the channel width, right? So channel is less means narrow, then less holes will be flowing, ID will be less. If it is increased, then more ID will be flowing. So ID is actually flowing due to the width of the channel. So channel width is controlled by the gate terminal, that is we are applying the voltage at gate. So gate voltage is actually controlling the current. So this is the working. So you can see ID is coming outside. So what type of channel is it? This is P. So P type channel, or we can say P channel. Channel is already there. That is depletion type. So it is P channel depletion type MOSFET, right? So I come to this. Okay. And channel, yes, P channel here, right? So you can see this arrow is outside. So what is this? P channel. So how do we draw it? I am drawing one. First, connect, draw it, gate. Draw one line. This is drain, this is source, and this is, what is this? This is actually the body terminal, SS, that is connected with S. What we did here? This S and this SS both are connected, right? So we are doing the same here. This SS and S both are connected here. Now the direction. So direction is outside, so it will become P channel. So in depletion type, this line is completed, while in case of enhancement, it is incomplete because channel is not there. Channel is not there, so we can draw here. This is gate. We will draw three lines. This line is of drain, this line is of source, and this line is of body. So it is outside. So it is P channel enhancement type. Enhancement, why enhancement? Because we have to develop the channel. Channel is not there, but we will develop. In case of this, it will be. So if it is completed, then it is depletion. If it is not it is not connected, then it will be enhancement. Understood? So is there any need to remember the symbol? If we understand the structure and working, you can draw the symbols of both FETs and MOSFET very easily. Understood? Any doubt to anyone? Shall we proceed? So what is the advantage? So advantage is first important thing, that is the switching speed. Switching speed means the speed of working is very fast than BJT, and we are using digital circuits in most of the appliances, so it is useful for digital logic circuits also and power supplies. Another advantage is high input impedance than BJT, and also allow where low power consumption is important. So power consumption is also less than that of BJT. But also disadvantage, that is sensitivity to static electricity and other form of electrical interference. So it is more sensible, right? It is more sensible in case of static electricity. So we should not means we should not use that type of appliance or component which is very much sensible, right? And this can cause damage also. If some fluctuation is there, there will be damage. Okay, so it is also the problem. And high precision application. And also one disadvantage, that is low output resistance, which can make them less suitable for use in high power application. So in high power application, the output impedance should be high, but there is low output impedance, so there is also the problem with FETs. MOSFET MOSFET is very much useful in inverters. You have seen inverters. Inside MOSFET, they are inside inverters. MOSFETs are used because we are using digital logic circuits there. Okay, and in microprocessor and other digital devices, we can also make FETs and MOSFET. That is very much suited with them. And low noise amplifiers, voltage control oscillator VCO. It is known as VCO. VCO is actually oscillators. Oscillators are the devices which are used to generate the signal. So voltage control oscillators are also using GFET. You can see IGFET, IGBT, that is uh, for transistors and high power application such as motor control and power electronics. Power electronics is high power electronics, means in case of power electronics, high power appliances, production companies, and so many things are there. So they are using power electronics. So they are also preferring FED MOSFET. So today we discuss about the amplifier, that is use of transistor as an amplifier, FET, MOSFET, right? And what we used, these are the keywords that we use, that is gate, source, drain. So gate was base in case of BJT, source was emitter in case of BJT, and drain was collector in case of BJT. And here it is channel. So channel is actually what type of material we are using as a base. So if we have used N type bar, then it will be N channel. P type bar, that is P type or P channel. So these are the some questions, that what is GFET. You can give the answers of that. When was the junction field effect transistor was invented? GFET contains how many diodes you can see. So PN junction, right? So after diffusing two reasons, we had two. What is difference between BJT and FET? What are the important uses of transistor we have discussed? What is MOSFET? Can it be conduct in both? It is not possible. What is difference between MOSFET and BJT? Which type of transistor is known as unipolar? So it is FET and MOSFET. What are the operating regions of MOSFET? So in this case, we can give the answers. So this is all about the today's session. If you have any doubt, you can ask me. Any doubt to anyone in any of the topics? Any doubt? Okay, so we will meet in the next session with a new topic. So thank you so much. Happy learning. Thank you. Thank you so much. Thank you, Minal. Same to you. Thank you. You can leave and join the next session if you have. Moderator, please end the session. Thank you.